So E of n equals -1/90 n squared plus 2/3 n. Excellent. Now I put it in the correct order. What do I do next? What is the problem asking me to do or find? How do I address this?
So that becomes maximum. So
Exactly, that's all I care about. I need to find the vertex. Say it again. Exactly. -b/2a. I have to be very careful. I need to carefully identify a, b, signs, everything. I'm ready when you are.
So 2/3.
Indeed. Minus in front, we have to copy the minus. So b has to be 2/3, and the denominator I have to write 2. I have to write parentheses, careful. And what is, and yes, -1/90. This is my colleague, and he's the author of that handout that I gave you the first day of classes. We observe each other's classes. I sat in his class for the entire semester in one of his classes about 15 years ago. Very good. So I have to be very careful. I have a minus in front. I have a minus inside. I have to carefully master this. This is going to be the number, right, that will give us the maximum. Can the number be negative?
No.
So that's another thing that I should keep in mind, right? So I have negative and I have negative, and it's multiplied. So I have 2/3 at the top, and then 2 multiplied by 1/90, and I will simplify by 2 and get 45. So the fraction at the top is 2/3. The fraction at the bottom is 1/45. Exactly. I copy 2/3 and I multiply by 45/1. I will simplify. That's the key here. I'll simplify and I get 15, and the answer is 30. So if the model is correct, I have no idea for sure if it's still correct. Maybe this was done 10 years ago. Maybe it's not still valid, right? But if the model is true, then a person or a viewer should see an advertisement 30 times, should be bombarded 30 times in order to maybe make a buy. Now, let's say the question is asking us also to find that maximum. What do I have to do to find the maximum, which is it's called, one more time, the effectiveness. Exactly. So let's find E of 30. -1/90, 30 squared, 900 plus 2/3 times 30. Remember what the problem was saying? The number must be between 0 and 10. It should be. So let's see. So 10, so -10 plus 20 equals 10. Indeed, the maximum effectiveness is attained when the viewer is bombarded 30 times with the same over and over thing. Any questions?
You automatically assume that the maximum will be 10 since in the problem it says the range.
Yes, but it normally doesn't say, and will ask you to find it. So that's why I wanted to make sure that you know to plug in. Okay, very good. Next. Polynomial functions. And you can say, well, what was this one? True, it was a polynomial function. But now I'm looking at higher degree. Like 3, which we already know a little bit. We know the base. 3, 4, 5, 6, and so on and so forth. So degree of higher degree, like 3, 4, 5, 6. I think that's good enough. Because once I know how to graph the first and the second, I will be able to graph any degree. And I'll explain how. Okay, so odd degree, even degree. We do know a polynomial function for each degree, and we know it inside out. Which polynomial function of odd degree we know in our dreams?
Cubic.
Linear. Yes, we know cubic, but not in our dreams. We know linear in our dreams. And which one we know in our dreams as an even function? Yes. Under linear, there are two possibilities, right? Under linear, we have this possibility. What is the leading coefficient here? And we have this possibility. What is the leading coefficient here? We know that. We have two possibilities for quadratic. And what is the leading coefficient here? Leading coefficient. It's our x squared. We know it in our dreams. What is the leading coefficient of x squared? Right, right? And what is the leading coefficient of this? How do we get it from this one? Right. Very good. Everything else will follow this pattern. Everything else will follow this pattern. Now, what is the next degree? So this, what is degree is this? 1. What degree is this? 2. Give me the third degree and tell me where will I put it?
It's going to be an odd function.
Not all of them. Not all of them, right? But if you're thinking of x cubed, I have to agree. But not all cubic functions will be symmetric. Good? So obviously the x cubed or the cubic function, will you put it in this category or will you put it in this category? No, not odd. Yes, odd degree, of course. Odd degree, absolutely. So if the leading coefficient is positive, here will be anything that has degree 3 with a positive leading coefficient. It will follow the same pattern from negative infinity to positive infinity, from negative infinity to positive infinity. What do you think will happen? How will I graph a cubic function with a negative leading coefficient? Exactly. Yes. It has to follow the same pattern with a linear function with a negative leading coefficient. It's a must. Okay, now I want you to give me the next level. What will be the next level? Yes, so this is cubic. Where will I put it? In which category? Left or right? Right, because it's an even degree. Very good. So this will be 4th degree. Good. How do you think it's going to look like if the leading coefficient is positive and if the leading coefficient is negative? If it's 4th degree with a leading coefficient that is positive. Exactly. Whatever it does, I don't care in between. But it has to follow the same pattern with x squared with a positive leading coefficient. Finally, if it's 4th degree with a negative leading coefficient. Whatever. No, this is not going to have that many. I'm just, exaggerating. It's not going to have that many terms. But that's the pattern. Okay. Now, the next one. Any odd degree that you can think of, if the leading coefficient will be positive, this will be the case. If the leading coefficient will be negative, this will be the case for any degree you want. Now, what if the degree is even? At any even degree with a positive leading coefficient and with a negative leading coefficient, it will always follow the same pattern with x squared, something like this or something like this. Okay. I would like us to choose a cubic function, not just x cubed, more complicated than that, so we can go through the whole step, the whole procedure. I did not forget We finish at 6:45. I know. Okay, so let's choose a function. Either we are on page 244. Either a function that is already factored, or a function that we need to factor. It's up to you, whatever you want to choose, because I'm going to choose a cubic and a fourth degree anyway, or an odd and an even. So from 15 through 40, choose any problem you want. 36. Where are you, 36? I see it. Perfect. So 36.
It's not cubic.
Oh, it's not cubic. I need a cubic first. Which one? 33 is cubic, yes. So 33 on page 244, and we have p of x equals x cubed plus x squared minus x minus 1. I think I can remove this now. Yes, I can. Okay, perfect. What type of function is it? So where will I look here? I will not come back with this. I don't need it anymore. But or I should say, will it look like just the end behavior? Of course, it's not going to be a linear function. It's not going to be quadratic. But will it look like this, or this? 1, 2, 3, 4. Exactly. Because it's in descending order, it has a positive leading coefficient, and it has to look like this. It has to come from negative values and go to positive values. The degree is 3, so it has to be in this category, and it has to look like this, for sure. Perfect. Okay, so here we are asked to graph p of x. There are a lot of steps here that I have to worry about. First of all, one of them that I know it's very clear, no doubt, is the domain. What is the domain? And I can express that directly in my chart. Once I put negative into infinity, it's very clear that I know the domain is all real numbers. Good. That's my first step, domain. Step number 2. I have to find the X-intercepts and their multiplicities. Sorry, I didn't have enough room. Multiplicities. I can write the word one more time here. What is that? Multiplicity. The multiplicity is the number of times that particular x-intercept appears. Okay? Multiplicities. Number of times a 0 or an x-intercept appears. Okay, yes, I have to factor. So how do I find the x-intercepts? What do I have to write? Exactly. P of x equals 0, so I have x cubed plus x squared minus x minus 1. Right here, I need to identify the degree. We already know the degree, but I have to write it. Yes, the degree is 3. What does that mean? How many x-intercepts, real or imaginary, I don't care, how many x-intercepts will I have to present? Absolutely. They may be imaginary, I don't know, but I have to find x1, x2, and x3. Perfect. First step. Yes. So x plus 1. And I have to have an x plus 1. And what goes in front? Very good. Negative 1. And next, what do I have to do? Factor out x plus 1. What is left in parentheses? Okay, I have an agreement on this.
X plus Y.
So
So X equals -1.
twice, that's the multiplicity, and x equals 1. So what is the multiplicity of -1? Number of times an x-intercept appears. Yes, so for x equals -1, multiplicity 2. For x equals 1, multiplicity 1.
Can you spell it again?
The number of times an x-intercept appears. X equals -1 appears twice. X equals -1, x equals -1. Very good. Yes.
So the degree, the number, the degree is that the number of multiplicity?
No.
Or
The sum of the multiplicity has to
Okay.
equal the degree. Correct. Yes. If the degree is 5 and one solution appears 3 times and another one twice, of course, multiplicity 3 plus multiplicity 2 will be equal the degree. Absolutely. Yes. Very good. Now let me discuss multiplicities a little bit more before we move on to step 3. Okay. So for odd multiplicities, what do I mean by odd multiplicities? A solution appears once, appears 3 times, appears, and so on and so forth. If it appears once, M1. If it appears 3 times, I'm sure you remember x cubed. When we graphed x cubed, we didn't graph it like this. Here's how we graphed x cubed. Why? What is the multiplicity of x equals 0 in the function x cubed?
That's 3.
Exactly. That's why it crosses at 0. There is still one solution. There are no 3 points in there. But because the solution appears 3 times, the function does not do this. It does this. What about multiplicity 5? How will that look?
Does it round out longer?
Exactly. It will take even longer to cross. So I'm going to extend this to show.
The general shape is the same.
Exactly. No change. I'm talking about the intercept, the x-intercept. I don't care about the shape, where it's going. Oh, if you want the other shape, that's fine. I can do that. So it's this. See the difference between these 3 points? Huge difference. And this is multiplicity 5. Now this is extremely important. The calculator is not as sensitive. It will show a difference between, but not that much between these two. Okay? We have to bring this knowledge with us. Okay? So if multiplicity is 1, it crosses. If it's 3, it crosses slowly. If it's 5, it crosses very slowly. And of course, and so on and so forth. Okay. Now what about even multiplicities?
Hang on, so when you're saying that it crosses slowly, there are more x points.
No. It gets closer and then 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 closer, crosses and then closer and then closer and then closer and then closer. It takes like forever till it branches off. This one is even multiplicities. What about multiplicity 2? How does this look? We already know a multiplicity 2. Which one?
quadrant.
Of course, x squared. Here's multiplicity 2. M equals 2. What about 4? Slowly, slow, 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 slow.
These are all different points on that.
No, this is x equals 5 4 times. This is x equals 0 twice. This is x equals 10 5 times. This is x equals 0 3 times. This is x equals -5 once. I just showed how it looks like. So coming back to our function, for multiplicity 2, when x is -1, -1 comma 0, which one will it be? Yes,
So
It's just gonna be longer at -1.
right here. Something like this. What about multiplicity 1 for x equals 1?
It's no problem.
Something like this.
Okay, that makes sense.
Okay? Perfect. Good. Number 3. We already have, so we have the degree, we have the multiplicity, we have the x-intercepts, the y-intercept. The first example, it takes so long because I have to explain a lot of pieces here. But once we go through this once, the second time and the third time will be very quick. Very quick. Okay, y-intercept. How do I determine the y-intercept of this function? Yes, p of 0, which is? Perfect. So the ordered pair we just determined is?
that's 0, -1.
Perfect. Number 4. Maximum possible number of turns is the degree -1. Maximum possible number of turns is the degree -1. The function doesn't have to turn that many times, but it cannot turn more than that. So what is the degree of this function? And in our case, how many turns can this function have at the most? 2 turns. What about x cubed? X cubed, how many turns can x cubed have? The degree -1. 2. How many turns does it have?
2.
None. X cubed has no turns. Remember we graphed it? So this is x cubed. How many turns does x cubed have? Meaning max min. That's what I mean by a turn. Right? So how many turns does it have? How many turns can have maximum? 2. Degree -1. But it doesn't have any. So it doesn't have to have, okay, that many turns. Okay. Number 5. Max or min with a calculator. In calculus, we don't do this with a calculator. We can do it by hand, but not here. Here we have to use the calculator. Number 6. And behavior. I already have it because I identified the function here. We already circled the function. I know it's this. So what would be the end behavior? From what? It's from 2? Exactly. So I'm ready now to go back and fill in my chart. Okay. In my chart, you already told me the end behavior. So -infinity to +infinity. I'm going to put it right here. You already told me that at 0 is -1. You already told me the x-intercepts. What are the x-intercepts? So -1 comma 0, right? negative 1 comma 0, I write myself a note here. Since it's multiplicity 2, what will the function do?
Just take a little more.
Exactly, and we say turn. And then you said 1 comma 0, right? And I'm going to write cross. So it's freely, it's going to cross freely at 1 comma 0, but it will have a turn at negative 1, 0, and it will cross the y-axis at 0, negative 1. Yes, you can come up with 10 million points if you want. If you say, this is not enough for me, you can come up with any number of points you want. You can plug in any x and determine the corresponding y. I think,
Sorry,
go ahead.
you said it turned, so at negative 1, 0, it turns, and then you say it crosses the x-axis at 0, negative 1?
No, that's the y-axis at 0, negative 1.
Sorry, y-axis.
Yes.
And then it crosses the x-axis at the 1.
We determine the x-intercepts. We have 3 x-intercepts.
Right,
We
I
have a
just wanted
multiplicity
to
2.
turn.
Yes, yes, yes. So at negative 1, we have multiplicity 2. That's why it's a turn. At x equals 1, multiplicity is 1. That's why it's a cross, because of this. Multiplicity 1, it's a cross. Multiplicity 2 is a turn. Better? Okay, perfect. So now, with what I have, you can say it's not enough. Let's give it a shot. From left to right, it is very important to understand these functions, and you will have no difficulties if you stay with me and follow me through. Okay, so the first point that I see, it's negative 1, 0. So I'm going to plot that. The next point I see is 0, negative 1. I'm going to plot that. The next point I see is 1 comma 0. I'm going to plot that. And now I'm going to do the following thinking. The function is coming from negative infinity. It will come to this point on the x-axis, but it will turn. Okay? So watch, don't write anything. Let's just watch for a second. It's coming from negative infinity. It's coming to the first point that I plotted, but it has to turn. It's coming from negative infinity. Touches the x-axis at negative 1, 0, but it's a turn. Then it has to come down to this point. I don't know if it's going to turn here. I don't know if it's going to do this. That part I don't know. In pre-calculus is not good enough. So I could have this situation or I could have this situation. I'm not sure. I think it's a little bit stretching it to do this. That's not possible. I don't think that that's going to be the case. You picked the problem. I didn't even look at it. And then it's coming up to cross the x-axis again at 1 comma 0. So either this and go to infinity, or this. That part I don't know, and I'm going to check with the graphing calculator when I determine the minimum and the maximum. So one more time. The function is coming from negative infinity, and now we can graph it if you'd like. Coming from negative infinity. It's coming to this point, but I made myself a note. It's a turn. Then it crosses the y-axis at 0, negative 1. And then it has to turn somewhere because it comes back to 1 comma 0, crossing it and going up to infinity. So this is our function, p of x, which is x cubed plus x squared minus x minus 1. And now I'm ready to look at my graphing calculator, go to y equals. Please wake up. Okay, so x cubed plus x squared. Oh, of course. X cubed plus x squared minus x and minus 1. I'm not going to just simply click on graph. I'm going to think. I know that the action happens all around negative 1, 1, negative 1, 1. So if I have, let's say, the standard viewing window, negative 10, 10, and negative 10, 10, I'm fine. So I go to standard, so zoom, standard, and I'm looking for the graph. It has to turn, it has to cross the y-axis, It has to turn again. It cannot have more than 2 turns. We know that. Degree minus 1. So here's 1 turn. Here's the second one. And as expected, it goes beyond. It goes to the positive side. So everything is clear except this minimum. I know the minimum is between 0 and 1. So I'm going to go to second and calc. I want a minimum, which is 3. I'm going to say 0, enter 3, not 3, 1, sorry. 1, enter, and press, I don't want to guess. Just give me the minimum, please. So the minimum is at when x is 0.33, and the minimum is negative 1.2, roughly. I'll go back and put it in my chart. I will not erase on a test or quiz or final exam. I will leave it as is. I will not white it out or something. I will say not this, but this, because I want to show my professor that I'm thinking. Without looking at the calculator, I don't know if it turns here or turns here. It turns out that this is the correct graph. It does this. So I put my numbers in here, 0.33 and negative 1.2. And this is my local min. This is my local max. What is the range of this function? Exactly. Absolutely. The range is all real numbers. This is how we graph a higher degree polynomial function. The rest are all the same. Now, please feel free to choose any function, because now it will take us 3 minutes, not half an hour as the first one did. Will you allow me to choose one?
Sure.
Okay, I am going to choose 26. On page 244. 26. P of x equals x minus 3 squared times x plus 1 squared. Perfect. The one thing that I did not mention, and we have to add it in on the list as the last item here in number 7, symmetry. In other words, if the function is odd or even. Let's look at the graph. Although, you know, we know the technique, we have to find f of negative x and show that it does not equal f of x and show that it does not equal f of negative x, because it's obvious. Okay, it crosses at negative 1, it crosses at 1, but look where the minimum is. Is this function symmetric with respect to the y-axis or with respect to the origin? No. So this is one other thing that I need to add. It's important to know. Okay, so quickly, I get my chart going. I don't have to talk that much. And domain, please. Excellent. Good. X-intercepts and multiplicities.
X minus 3 is equals to 2.
So x equals 3, multiplicity 2, and x equals multiplicity 2. So negative 1, 0 has to be in the chart always, and 3. And I'm going to write what? 0, 0, of course. What am I going to write for the point negative 1, 0? I can write cross. I can write cross flat. It means slowly. Turn or turn flat. Just turn. Turn flat, it will be multiplicity 4. So turn, good. So let's plug in 0 and see what we get. Zero minus 3, negative 3 squared. 9 times 1, 9. And behavior, please. What about the degree? I should ask the degree first. Okay, x squared times x squared. Of course I didn't choose degree 3 again.
So degree 4.
Exactly, because it's x squared times x squared, right? Look at this. Multiplicity 2, multiplicity 2. This cannot be degree 3. We have 4 solutions, right? Good. Degree 4. Max possible number of terms. It doesn't have to have that many. Exactly. It cannot have more than 3, but it doesn't have to have 3. Okay, perfect. Now next, end behavior. What is the end behavior here?
It's going to look from negative infinity to possibilities. It's going to be a slow turn.
Let's go back to our chart. The chart will tell us where to look and what type of function is it. Is it odd degree or even degree?
Even degree, so
Does it have a positive leading coefficient or a negative leading coefficient?
positively.
So what will be the end behavior? I'm not interested in anything in the middle. I'm interested in the end behavior. Exactly. Exactly. That's the end behavior, right? It's this or this. Yes, because it's a positive leading coefficient. It's even degree, so it has to come from positive infinity to go back to positive infinity. It's a must. So infinity and infinity. The only thing is symmetry. I will accept if you go ahead and graph it, not with the graphing calculator first, grab the calculator and graph it. No, I want you to think. And then I'm happy if you just mention f of negative x does not equal f of x, and it does not equal negative f of x. So I know you know what it means. And I'm happy because it's not symmetric. Okay, so now let's give it a shot. Please, let's give it a shot before we look at the graphing calculator. That's the whole trick. That is what is useful. Everyone can grab the calculator and graph it with the graphing calculator. Right. Okay, so first point that I will plot. Can anyone dictate?
0, -1.
Negative 1, 0 is right here. The next one. Okay. 1, 2, 3, 4, 5. That's what happens when you don't plan ahead. 1, 2, 3, 4, 5, 6, 7, 8, 9. And negative 1. Okay, perfect. And 1, 2, 3.
Can you slide it up?
Yes. I only plotted those points. Okay, very good. So now I'm trying to make sense of the information I see. It's coming from positive infinity. It will get to this point on the x-axis where it has a turn. So coming from positive infinity, it's coming to this point, it has to have a turn. Then it's going up to 0, 9. Okay, it's going up to 0, 9. Again, I have no idea whether it turns here. It's kind of forced. I think it's going to continue, but I don't know. I will have to check. I show my professor, then I'm thinking there are 2 possibilities. It may turn here, or it may go further. And then it's coming back to touch the x-axis again at 3, 0, where it has a turn, and then it's going to infinity. So it's coming back. I'm going to say either from here, or from there. And it has a turn, and it's going up to positive infinity. Now I am ready, and I'm allowed to look at the graphing calculator. This is our function, x minus 3, everything squared, x plus 1 squared. We'll correct the graph now. We are allowed to. And I'm going to put it in y equals, clear, parentheses, x minus 3, close, squared, and parentheses, x minus 1, no, plus 1. X plus 1, and everything squared. I'm thinking again, it has to go up to 9. I I think I'm going to go higher up on the y-axis. I don't really need to see anything below the x-axis because it doesn't go below the x-axis, but I really need to see more up. So I'm going to change the viewing window. X minimum -10, X maximum 10, it's okay, but I want Y minimum to be -4, not more than that, not lower than that, and I want this one to be 20 with a scale of 5. I don't know. It may or may not work. I may be able to see the top, the turn, or not. I am. So it does cross, as you see, at 0,9 because I have here 20, 5, 10, 15, 20. So as expected, it's not going to force a turn. These polynomial functions are very smooth, continuous functions. If you have to do this, then something is wrong. So they are very smooth, continuous functions. So obviously that would have been forced to turn at 0,9. It goes all the way to, I'm assuming, I don't know, 15, 16, 17 maybe. I'm going to have to find this maximum. It's between x equals 0 and x equals 3. I go to second and calc. I want a maximum. And I want it between 0, enter, 3, enter. I don't care for a guess. Just give me the number. So it's at 1, and the maximum is 16. So now I can go back, correct my graph, and say 1, 16 is the local max, and this is a local min, and this is a local min, and also these two are global or absolute min. There is nothing lower than 0 for this function. Any questions? Any questions? So here, of course, for symmetry, I will write none. Function is not symmetric, of course. None, not symmetric. So here's the graph. Of course, I'll cross this out. That's not the case. This was my attempt. I tried to, no, it was kind of difficult to turn. Look, if I have to bend my wrist like that, this cannot be it. Any questions on how to graph polynomial functions of any degree? So now you can graph on your own degree 5, degree 6. Don't go beyond degree 5 or 6. I'm fine with 5 and 6. Parker?
So for the local min,
Yes.
the 0.30, like
It's a local min. It does not go, and yes, because I can show the open interval around it, in which all function values are higher. This is the minimum.
Yeah, I didn't know if you circled that as a local min.
Yes, both of them. Yes. Oh, I'm sorry. Yes, both of them. So this is because it's 0,
Okay, yes.
right? And they on the graph, and it's also absolute min because it doesn't go below 0. Any questions? We decided to meet tomorrow, correct? Yes, everyone? Chris? Yes? So 4:15 to 6:15 in this room. I have another class from 6:30. Now, if you want me to wait till 6:20, I can. You can text me and tell me, say, wait till 6:20. So I will see you